Hello watchers, welcome back with another video by Coach. And in today's video, we're going to talk about the monolithic server and microservices. Okay, so we will dive deeper into the microservice part, but I'm just going to give you an example of how a monolithic server looks so that you can understand microservices as well. Okay, so let's start with this monolithic server. So most of the time that you will see, like people would have like these monolithic server. Especially when someone starts a project, even like some of the startups, you will find this thing. And there was a recent news where I also read that even Amazon actually shifted their platform, basically Amazon Prime, from like microservices to monolithic. So as I said, it's not like this particular concept is really bad. It's not that. It's just that like what works for you might not work for other people. So choose things according to your need, not because it's trending. So first of all, let's try to understand what monolithic servers are. I mean, the monolithic server is, and then we will see like what microservices are. So how monolithic server work? So here, what you will have a particular one server. Okay, so only one server. For example, let's assume this is like our Node.js server. Okay, and where we have defined our different routes like users, products, and orders. We have these three services all inside one particular server. Okay, which is like this monolithic server. Like you have every kind of service feature and every functionality inside one particular server. You manage everything in there over there. And all of these services, because you can assume like these are the schemas of our uh, data model, like a user schema, product schema, order schema. These are the three different services, and all of these schemas are stored in one particular database, which is this one. Okay, so all these are connected to this one. All these things, I mean, all of these are actually storing their data here. Okay, is in this database. Now what happens whenever user sends a request, this request goes into one of these route. Okay, and then that route actually processes all of the thing that it needs, like a business logic, and execute their business logic and process the data, fetches the data from the database and bring it and create the response, and then it send it back to user. So far it's good. Okay, so that's what monolithic server is like. You basically manage everything at one place. Now the problem with the server is like it's really easy to understand, because you can see like it's a pretty much simple. Like you have a three services, three dot defined, and you will make a request and you will fetch data from one database. So even if this user need a particular product, then you can access basically right from here. Okay, so yeah, it's pretty much simple. So that's how it works. And the problem with this thing is like if this server, like here you can see like this is a single point of failure, because like there's only one database. Okay, so if this one goes down, then all of the services would stop working, because these all are connected to this one. Okay, so this database should be running in order to run this data should be always live. Only then these services will work. Like this particular server will work. So this is the problem with the monolithic server, but at the same time, also it's easy to maintain, not to maintain, but it's easy to understand the entire flow, like how the data will flow from one side to another side. Now let's take a look at microservices and how that would work. Okay, so now let's talk about microservices. Okay, so microservices are kind of an architectural style, which basically how it works. So here, each service will have their own servers. Okay, own server, like just like unlike a monolithic where we were storing everything, we were managing everything in one particular server. Okay, like a user, product, and order. Here, each of these will have their own service. Okay, these will be microservices. That's why it is called microservices, because you have like different micro level services. Okay, so here user will have their own service, product will have their own service, and order will have their own service. Now because here you can clearly see like it's a very modular, because you have separated every single service into different service. Okay, every single functionality and thing like you into different service. So that's why it's very very modular. And the best part of this thing is like it has a concept of like a database as per service, one database as per service. So which means like there will be three different database, and each database will be connected to one service. Okay, so it is not recommended to actually like you go and access a product from like this user service, because then it will basically doesn't make any sense, because then you are violating the rules, because you are accessing then you are making it interdependent. Okay, so let's say for example, just for example, I mean, if I'll show you, if you will let's say if a user need product, okay, product detail, if you will access the data from here, then it would not make any sense. Okay, because you are accessing from here, then it is just similar like a monolithic, because here now it's interdependent. So in case database 2 fails, then your user service will also fail. Okay, so because it's connected to this one, so that's why it is recommended to keep one database per service. Okay, and these should be isolated. Okay, so this is what this is how microservices looks. Now as I said, it's a scalable, because each of these are isolated and separated into different modules, not modules but like a different micro level services. So that's why it's easy to maintain. So in case if you need an extra feature, then just add a one new microservice if you need. So and even like in any of these requires external database storage or something like that, okay, then you can just increase the capacity of that particular service. You don't have to do it at a like big level, like don't have to like do at this level, like you don't have to like increase the RAM, ROM and capacity of everything, because here each of these are isolated. So this is the one of the best thing about microservices. And as it's isolated, so these are not interdependent. So even if one of these gets even if one of these crashes, then rest of will work easily. Rest of them would work, okay, without a problem. So this is the best part of microservices. But there are some disadvantages as well, which we will talk about later in this video, in which one of these are like it's really hard to maintain, because here you need to establish the communication between these different services, like how they would talk to each other. Okay, like as I said, like you can't access the data from user service from like a product service and product, like vice versa. It's not like you can access the data of database 2 from like a user service. It's not recommended. So you have to find a better way to communicate, establish communication across these services. Okay, so that's one of the problem that you have to face. And apart from that, there is also data consistency that you have to maintain, because you are uh, yeah, because these are the separate details, these are the separate services. So how the data of this looks, only this one knows. Okay, so you have to make sure like the data consistency should be there. Okay, because in case of monolithic, what happens, like you manage everything at one place, so you have an idea like how things are defined. But here you don't have an idea. You have to like basically contact the owner or like a maintainer of this service, like whenever they make any changes. Okay, so in case if they forget, if in case he or she forgets like to tell you like, hey, we have made this changes, then yeah, it will be a problem for you. Okay, not so it's also, it only happens when you use like a http request sort of method to communicate between each of the services, among these services, when you try to establish the connection. So that's the one of the problem. And apart from that, there's one bigger problem, like one of the most, you can say like I think it's like a 70% of uh it comprises like a 70% of problem, which is like a communication that I was talking about. So you have to understand, you have to find out like what will be the best way to establish communication between these three services. So let's say if there are like a fourth service. Okay, for example, let me just copy this one, and let's create a service D. Okay, I'm just gonna name this day, and this will have a database for, or you don't even need database if you don't want. Okay, so that's totally up to you whether your service needs that or not. But I'm just gonna explain you what it's going to do. So let's say service D wants that find out all the products ordered by a user. Yeah, find out all the products user ordered by users. So how are you going to find that out? So if you'll go back in like a monolithic server, let me wait a minute. Okay, so here you can see. So in case here, if I have like a service D here, in case, so what I will do, I will basically use user ID and use product ID. Okay, and on the basis of that, I can basically filter out, like, I don't even need that. Okay, so basically on the basis of user ID, I can see like what kind of products he has ordered. Okay, because it will be in the list. But in case of microservice, as I said, like, because you can't access of a database P321, so it's not like you if you're using service do, then you can directly access like a database of a user. So that's why you have to find out the best possible way to actually get the data. So there are like a different methods that people uses to solve this problem that we, that we will talk about in the next video, or maybe in next session. Okay, yeah. Okay, so now let's talk about how you can communicate across these services. Okay, as I said, like, you can't interact with others databases, other services database. So how you can actually access the data in this case? So there are like a different methods that we have, but the one we are going to talk about in this video will be event-driven approach. Okay, how thing works here? Like here, one you will have a event bus or something like that. Okay, and how these services will interact with each other. Like, let's say I've created here. You can see like the service D, which I was talking about. So this service D will what it will do. Whenever user sends a request, it will basically give him all the product ordered by him. Okay, all the product ordered by that user. Okay, so whenever a user hits the request here, then that request will contain the body or like a user ID or authenticated. If he might be authenticated, then we will extract the user ID of that person. And once we have that user ID, then instead of just accessing things directly here, what we will do, or we will emit an event. Okay, you can emit you can use any event driven system to implement this, but I'm just going to give you some sort of an overview like how it works. So it will emit an event. Let's say find out um, products ordered. Find out ordered products. Ordered, or I think I have written right. Products. Okay, something like that. It will basically emits this event, and now whoever service, like, whatever service will listen this event will execute the further code. Okay, so let's say this event will get added inside our event bus. I think I've added like a big one. Okay, so now what will happen? So this find out ordered products. Okay, so this will okay, so order service will basically listen this find out ordered product event. So whenever it gets this event, it will extract the user ID from it, and it will send that user ID, not send that, it will basically filter all the orders that contains user ID with user A. Okay, and once you did, or I mean, once it has all the orders ordered by user A, then each order will contain us products. Okay, like an array of products or whatever you can say, and then we will further send that product. We will create a further event. Okay, like another event. with a different name. This time we will have find product details. Okay, and this is the event. This is the event emitted by this order service. Okay, and who will be listening to this event? Product service basically. Okay, so product service is basically listening to this event. Now what it will do, it will find the details of all the products that is mentioned here, and it will emit a further event, which will basically not a further event, basically it will return the response to order service. Okay, and then order service will further return that response to service D. Okay, so that's how it will get all the products ordered by user. Okay, I know it's kind of a complicated. I haven't drawn it particularly like completely, but I think you've got an idea like how it works. So yeah, that's what it is. So this is like an event driven approach. You can learn more about this. I will mention the articles and things in the description where I basically read to make this video. Okay, so now let's move to the another one, which is we're going to talk about the materialized view. Okay, so how that works. So, but before that, let's try to understand the drawbacks of this event-driven approach. Here you can clearly see like service D is dependent on these three services. Okay, so even any of these services goes down, then it will stop working because it is fetching the data from these two services at least. Okay, so it is still kind of a dependent on these two services. So to overcome this problem, we have another way to access data, which is called materialized view. Here, what you do, like you create a copy of the things that you need actually. Okay, only you don't copy, you don't create like a entire schema or like exact schema of this product and order. But what you do here is it will have their own database. Okay, because it's a microservice and it will have their own database. But instead of like copying the entire data, it will only store the data that it needs. Okay, that particular service, so this particular service needs to fulfill its goal. Okay, basically to find out all the products ordered by user. Okay, so to achieve this thing, we use a method called materialized view, which we will talk in a while. The thing is, it actually adds complexity to your entire system, because now you are creating a copy of a data and managing that. But the best part of it is like now all of these will be independent. Okay, so let's say in the future any of these goes down, it will still work because you are connected to this database, not these services basically. Okay, so that's the one of the best part of this. So let's try to understand like how it works. So let me just remove this one and then we will focus on that. Yeah, let me remove this one and this one and this one. Okay, so let's try to understand like what kind of information we need actually. Okay, if we are creating a database for service D, so we need user ID and although I'm just randomly drawing, so don't mind if I do a mistake. So we will have a user ID, and whenever there will be a product created, then we will keep the reference of that product. Okay, all the products ordered by a user. Okay, I think these two will be enough for us, right? And there should be like order ID as well. Okay, so yeah, so these are the four things that we need. Not ID, sorry to say, it's not ID, but we will rather use a very specific thing, which is, let's say in case of product, it should be product name. Okay, truly product name, and here we can like use order ID. Yeah, it's fine, because we are not going to query this on the basis of this product ID, because you're not going to access these databases and these services. So it's important to keep it as clear as we can. Okay. So we're going to store a product name. There will be an order ID attached to this user ID, and this particular user ID will have all the product. Okay. So now what happened, it will also use a little bit of a event driven approach, but not like it's like a one way. Okay. So how it would work. So now whenever someone will create an order, let's say now if a user will create an order, so he will create an order with the product ID, right? So with on the basis of that product ID, this will create a order. Okay. So once it will create a product and the product ID, then what it will do, it will basically send that, it will store that thing in their database db3. Okay, but at the same time it will also create an event that which you can imagine, like I'm just drawing it randomly here, but it will uh, emit a event with a name order created. Okay. Now when now our service T will be listening to this event, which will be order created, and it will extract all the useful information, like a user ID and the order ID and the product name. Okay, not even order ID, like a product name and things like that, and it will basically store that inside its database. So next time when user will request this, it will basically just extract the data from its database. Okay, it doesn't need to go to these microservices to access the data. So now it's completely interdependent, not independent, sorry, independent. So it can access data whenever it wants. So that's what materialized view is. Like here you basically owns a particular database for service that you want. Here you keep the record of important thing that you need in order to fulfill this particular service. At the same time, it also creates a complexity because now you have to manage separate database as well. But yeah, it's a kind of a trade-off that you have to keep. It's a trade-off kind of. Okay, so like it depends like what kind of thing you are doing. So choose a microservice pattern on the basis of your need. Okay, so yeah, that's pretty much it. Although it's not limited to that, like there are also other ways in which you can establish a communication like HTTP and inter-service communication and things like that. But for this video, I think these two will be enough.